All right. So let's go ahead and go through the syllabus first. Then we'll talk about the class a little bit and homework submission crap. We'll review some stuff from near the end of last semester because we kind of pick up where we left off, but I'm going to overlap a little bit since I'm sure, well, most of you probably practiced programming over break, I assume. Nobody practiced programming over break? Garbage.
I looked at GitHub a couple times.
You looked at GitHub a couple times?
Like the most recent submission from 200. That was about it.
No. It's very good. All right, so let's go in here. I think I have the class open now, right? Everybody can see the class?
Yeah.
So we're doing a couple of things different this semester. We're working on some different accreditation stuff. So we actually do have a textbook for in here. We're using something called Zybooks. I'll show it to you here in a minute. Let's look at it's under class and programming resources over here. Should have the syllabus, I think. All right, so this is me. This is my cell phone. So if you wanna, you can call me if you want. I probably won't pick up, but feel free to text me. Just tell me who you are. I'll reply to that. Email is also a good way of getting me. So text or email. Blah blah blah. Here's the crap about the class. Textbook. I'll show you here in a minute. We're using this thing called Zybooks, which is kind of an online interactive book for computer programming. So there'll be kind of normal book stuff, and then there's interactive. You want to pull the door shut there, maybe? Then there's like interactive exercises and stuff like that. I'll show you that here in a few minutes. Here's just your normal mumbo jumbo objective stuff. Let's see. Grading, homework assignments, 45% of your grade. Random pop quizzes, 15% of your grade. Midterm and final, each worth 20% of your grade. And as always, I have a policy that if you bomb the midterm and you do better in the final, I'll replace your midterm grade with your final exam grade. So you get 2 shots at the test, but not the other way around. You can't do well in the midterm, bomb the final, and want me to replace the final with your midterm. I won't go that direction. But in any case, that's the grading breakdown. Should be the same as it was last semester for those of you who had 200. So, questions about grading scale and that kind of jazz? All right, so somewhat often I'll give quizzes in class. It's right at the beginning of class. I'll come in and tell you to take out a sheet of paper. Higher probability of me giving quizzes when it looks like many people are skipping, because I do that to punish you, and also for my own entertainment. Also, when we've covered some interesting stuff the previous class, in fact, sometimes I'll tell you this would make a good quiz topic. So I do want you thinking about what we've done in class between classes. You almost always have homework assignments, so that'll work out anyways. But that's where quizzes come from, and they're worth a pretty substantial part of your grade. So you'll want to make sure, A, you show up to class on time so you can take the quizzes. I try to not make the quizzes trick quizzes. They should be based on things I've talked about the previous class or something like that. So hopefully most of you would do reasonably well on the quizzes as long as you're here to take them. The good news is the worst score you can possibly get on a quiz if you're present is a 30%. Whereas if you aren't here, it's a 0. So 30 is a lot better than a 0. So as long as you put your name on the paper, I'll give you a 30. is the punchline. All right. Any questions on grading and that stuff? All right. So let's talk about let's see. Oh, it's under assignments. All right, so with every one of your homework assignments, we have this homework submission instruction thing, so everybody has to read this, and I'm going to go ahead and we're going to go through it together here. So this is especially true with computer programming, as some of you recognize from last semester, especially once we got into the Java stuff, and we'll review that. So I recognize that some of you didn't pay attention to it over break, so we'll try to do some overlap. But computer programming is not easy. And I like to equate it to kind of like a sport. So if you play a sport, let's say the example I have to use is like basketball. So if you have aspirations to play professional basketball and you just learned what a basketball is today, so a complete beginner, and you go and spend 2 weeks at Michael Jordan's house doing the Michael Jordan basketball boot camp, you play basketball 15 hours a day with Michael Jordan, in 2 weeks, do you think you're going to be ready for the NBA? Are you going to be ready for the JV squad on a high school basketball team? Probably not even that, right? So even though you can academically learn different things, you can academically learn what a variable is, academically learn what a loop is or a conditional, without putting lots and lots and lots of practice in, getting used to using those things in various situations, you're not going to get better at it. So programming really is like a sport. Having said that, it is not something you can just cram for. So I promise you, if you blow off the first half of the class and you come in and take the midterm without trying to cram for the midterm the night before or something like that, single-digit grade is in your future on that midterm. And that's nothing against your intelligence. That's just the fact. That's how it, just like if you did the boot camp with Michael Jordan and then decided to play one-on-one against LeBron, it's not going to go well. you're gonna lose that. So in any case, with that in mind, something I expect you to do in your homework assignments is spend a lot of time on them. Probably more time than you spend on other homework assignments, because in some classes you throw an hour or two at a homework assignment and it will be done, right? It's time equals completion. That's not necessarily the case with programming, fortunately and unfortunately. But over time, the more time you spend learning all the stuff that doesn't work, the less time you'll end up spending in the future. So things that might take you 10 hours to not get done now, by the end of the semester, you might be able to do that in 15 minutes and it'd be easy. Okay, it's kind of the idea. Now, having said that, there might be a situation where you spend a lot of time on a homework assignment and have very little to show for it. Okay, hence the reason for the self-evaluation I want you to turn in with every single assignment. Okay, so before we read the stuff up top here, so there's 4 questions that I want you to answer with every single assignment. And just basically copy this and paste it into the little text box for homework submission. Just paste it right in there and answer the question. So the first one is, how long did you spend on the assignment? So I want to know actual time that you dedicated to this homework. Based on the effort you put in, how would you grade yourself? Okay, if you spent 10 hours on it and you have nothing to show for it, chances are you're going to give yourself better than a 0 because you felt like you put in legitimate effort and just sucked at it, right? Okay, so I want to know, based on your effort, what would you give yourself? Then based on what you actually submitted, in terms of the correctness of the answer, what would you give yourself? And then the most important one is the last one, is I want to know about your experience in doing this. So provide a summary of what doesn't work in your solution, along with an explanation of how you attempted to solve the problem and where you feel you struggled. Okay, so I want to know about how you spent that 10 hours. It doesn't have to be a big it doesn't have to be a paper or anything. Just give me a couple of sentences or a paragraph that kind of takes me through your experience of, potentially hell. Like, okay, I spent 10 hours. I don't even have Hello World working. It sucks. What I've submitted, I might as well have been math homework. All right, so that's fine. So now tell me all the things you tried. Tell me where you struggled. Tell me where your misunderstanding was, that kind of stuff. So I can go and give you partial credit based on your experience. Okay, so I don't have to give you a 0 in a homework assignment that you spent a lot of time on. The more time you spend on this explaining, all the practice you did that didn't show a successful completion, I could probably give you a 70%. Or something like that, a decent grade for the effort as opposed to for the result. Make sense? All right, so very important that you do this with every assignment. So important that if you don't, I'm going to give you a 0 on the assignment, even if your assignment is correct. Okay, so this is part of submission for your homework. Right? Sometimes I'm nice and I'll give you 1 warning if you forget it, but this should be part of your cadence. Every time you hand in a homework assignment, submit this with it. Okay? Even if was an easy homework assignment, how long did you spend? 15 minutes, didn't have problems with it at all. That's fine. Okay, you fulfilled your requirement. Okay, questions on that? So everybody understands that's with every homework assignment? All right. Let's see. Late work will not be accepted, except in true emergencies. So family emergencies, that's obviously acceptable. True illness, not like, hey, I got drunk last night and I'm puking when the homework should have been done before you were drunk. That's not acceptable. But, a real emergency, I'm not going to be a jerk about it. Okay. But, I had to work late, doesn't fly. I get it that real life starts earlier for young people today. So many of you might have full-time jobs and have all these other responsibilities. I get it, but also it's not my problem. So from a professor's perspective, you're a full-time student. So that's how I'm going to treat everybody. All right, so if you have taken on additional responsibilities, that's fine. It's your own prerogative, but don't use that as an excuse. If you're not going to do homework or you're not going to show up to class, that's fine. You're adults. That's the consequence. You get a 0 on the homework assignment. Fine. Don't ask me to let you turn it in late. Same thing with sports stuff. If you have an approved absence sporting event or something like that, that'll get you out of a quiz. So if you miss class because of a legitimate thing that the school has sponsored, I'll give you a pass on the quiz. I just omit it. I won't give you 100 on it. It won't count against you. I just make it so that you were omitted on the quiz, but not homework assignments. They're still due when they're due. All right. Questions on that? Okay. So that means I'm not going to have anybody come into my office saying, "Oh, I'm 3 assignments behind, but I'm going to get them into you. I'll turn them in." Because I'll say, "Okay," but I'm not going to grade them because I've already graded them. They're already 0s. So I guess do what you want, but I've delivered this message to everybody. So now it's contractually binding. Okay. So that's with every single homework assignment. Let's look at the textbook. So every one of you will have to go to this zybooks.com. You'll put in this code and click subscribe. I don't know what the book costs. I want to say it's $67. Okay, and that's like is that like a year subscription or something like that? It will at least last through the whole class. Okay. It'll last you through the class. So here's kind of the premise of this guy. So we're using it for several of our classes this semester. This is part of our assessment activities we're doing for this year, as well as we're trying to get ABET accredited. So I don't know, it makes your degree mean more. So I guess take it for what that is. Okay. So this is what you'll do to sign up. You'll go here, and ultimately what you'll get is what I have over here. So initially we're going to be kind of working through some of these, but I'm going to give you reading assignments from the book, but the assignments aren't just reading, they're also to complete stuff. So as you read through this, there are actual participation activities that you will do to complete and do different things. So it's very interactive as you go through this with some logic quizzes and that kind of stuff. And I'll see the feedback on these quizzes. So I'll know when you submit stuff and that kind of things. These aren't going to be graded exercises in terms of if you don't answer the quiz 100% correct the first time, the quiz is a learning exercise. But I'll see completeness. I'll be able to see that if I gave you an assignment to complete 1.1 through 1.3, let's say, I'll be able to see for each student what % you completed that. That make sense? All right, so so this is another tool for learning programming. So kind of an approach we're taking this semester, which is different than I've used in the past. So we'll see whether it sucks or doesn't suck. Is trying to give you ways of learning programming outside of just straight lecture. So that's going to hopefully benefit some of you that learn better with some hands-on stuff. So we'll try to do some in-class hands-on activities where we do some little programming examples and stuff like that, where it's less about just you listening to me for an hour and 15 minutes and hoping that turns into something. I know that works well for some of you, but one of our goals here is to increase the average competency we have of our graduating seniors in programming. Right now we have kind of a pretty polarizing situation where, let's say, half of our seniors are pretty strong programmers and half of our seniors basically can't do anything. We kind of like them to be able to do something. So we're taking a little bit different approach, and we'll see what happens. With that in mind, I'm going to have a, we're going to do a Survey Monkey thing, I think maybe every 2 or 3 weeks or something like that throughout the semester, where you can give me some anonymous feedback on how you think some of the stuff is going. If you hate it, you can tell me. It's not going to count against you. If you hate it and you want to tell me in person, it's not going to count against you. So I'm a pretty direct person. So if something sucks or just isn't going well, just tell me, and we'll, I'll either tell you you're being an idiot if you are. Otherwise, we'll try to come up with a constructive solution if something just really isn't playing out in class the way I intended for it to play out. Okay, so in any case, that's the textbook that all of you need to get. Okay, questions on that? Okay, some people have asked about an alternative text, like just for reference. Some of you want, and I think it's Didal Java. Let's go look at that. So this is kind of a de facto good, at the college level, good book. It's from this company called Didal, or a publisher called Didal. So it's Java How to Program. You can spend whatever it is, I don't know, $100 and some odd dollars or something on the most recent book, or you can just go to like books.com or eBay or something like that and get, version 8 or 7 or something like that of the book for $5, and 99% of it is going to be completely either the same or certainly applicable to what we're doing. All right, so if you're looking for an additional reference, I would not encourage you to spend top dollar on the newest, latest, greatest of that book. Spend $5, get it online, and somebody's used book from 2 semesters ago, and be done with it. Make sense? Okay, moving right along. We did the syllabus, we did the text. I'm going to do Codecademy here in a second. Let's talk about Slack channels. So most of you should already have access to this from last semester, but if you haven't been on our computer science Slack before, come to cuwcs.slack.com, and you can sign up with your cuw.edu email address here, and that will ultimately get you into our Slack channel here. And we have a CSE 250 channel in here that you can, that you should go ahead and join. I will put class announcements and things like that in here. The Slack app works for any of your desktops, so Mac or PC. You can get the desktop app. You can do it on the web page. There's apps for Android as well as iOS, and those support push notifications. So if you get Slack for your iPhone or for your Android smartphone, join 250, set up that you want to receive push notifications for it. Whenever I put an announcement out there for the class, it'll come to your phone as a push notification. Then you'll know, class is canceled, or I've modified a homework assignment, or an assignment is, due at a different date, whatever it is, that kind of stuff. All right, makes sense? I'm not going to grade you on the Slack thing, but I would highly encourage you to get it because there is always a possibility that I'll put an announcement out there that is like, tomorrow's secret quiz word is, and then it's just a quiz. You put in whatever I put on Slack and you get your points. So, make sense? That's actually a fun thing. It'd be interesting about maybe 2 weeks in just to see. Why am I just getting these random phone calls from like people I don't know? Just to see who's actually checking Slack. Yeah, that'd be a good one. Yeah, expect that. Remind me if I don't do that. All right, questions about Slack? Similarly, actually, so this is just for our class, but notice we have a lot of other channels here on Slack, and you can have private groups. So you can set up your own private groups on Slack, and students have often done this for like study groups. I encourage you in here to work on your homework assignments in groups, okay? I am not going to look through your programming assignments looking for people cheating. I want you to turn in your own work. So what I will look for is if you literally turn in an identical thing to somebody else without telling me. You know, if you submit something, they say, look, I worked with so-and-so on this, and it's going to look close. because we struggle with this, we worked on it together, just tell me. And I won't take points off. Because homework is for learning. It's not busy work just to get points. Okay? So I want you to work together on your homework assignments if you choose to do that, but with the goal of actually learning this stuff. Okay, so if you're struggling, try to identify, you know, a better, somebody who doesn't seem to be as struggling, somebody who's, you know, willing to work with some weaker students. For those of you who are stronger, I encourage you to do this because it'll actually make you better. Okay, if you can teach it to somebody else, you will become more proficient in it yourself. Okay, so for those of you who feel like you're ahead of the curve, I encourage you to help your classmates. It'll make you better as well. So if you want, you can just post in 250. Just say, hey, I feel like I'm pretty decent at this stuff. I'm willing to work in a group, especially if you live here on campus. I realize some of you live off campus. That might be less compatible, but I'd encourage you to get into some study groups, even if it's 4, 5, 6 people working together. It's fine. Get together, work on your homework for a couple hours, and hopefully the stronger people help the weaker people. And in the end, you all become better programmers and will do better on the midterm is ultimately what we're trying to do, right? You know, ultimately, if I'm not really looking for cheating on the homework assignments, do what you need to do to get a good grade on your homework. That's 45% of your grade, but also do what you need to do to prepare for the exams. Now, that's the more important part of it. All right, questions about Slack and the imminent Slack quiz. That's a great idea you had. I love that. All right. A couple other things we have on here. First of all, we have we used this last semester some. If you don't have it on your current computer, or you're going to be or want to reinstall it, we use the Eclipse IDE. We're going to be using this for part of the semester. So we're going to start off the semester doing kind of straight up Java until we get some tools under our belt. We'll review some tools we learned last semester and then, you know, build on that until we become hopefully relatively proficient. Certainly the second half of the class, so after the midterm, we're going to switch over to using a tool that's actually based on Eclipse. But it's called Android Studio. So we're going to do kind of some Android phone programming the second 8 weeks. So you don't be prepared to write the next Angry Birds, but you know, you'll be able to write some simple business type applications in Android using what you learned the first 8 weeks, and then part of what you'll learn the second 8 weeks is how to use the Android tool, the programming tool, along with the Java that you already know. Android programming is based on Java. Okay, so that should be kind of fun. And actually, Google's Android Studio was originally just Eclipse with Google's plugin for it. And they eventually took Eclipse, which is an open source product, and modified it to have all that stuff included. So Android Studio that you can download from Google's developer.google.com is actually Eclipse with their plugin in it and then reskinned to look googly. All right, but we'll be using Eclipse for probably the first 8 weeks. When you go to download for Eclipse, there's actually a newer version of Eclipse. So Eclipse Neon, I don't even know what version of Eclipse I have on this. Probably I have Luna, so I have the last model. They all look pretty much the same when you actually get them installed. So anything we do in here should map over pretty easily, regardless of what version you have. But the new version of Eclipse has kind of an installer built into it, which is a little bit different experience than it historically was. Installing Eclipse is, I think, easier now because it's an integrated installer rather than before. I think you basically downloaded Eclipse and it was just in a folder. And then it would yell at you. It just wouldn't work if you didn't have the Java SDK installed, and you had to go and get that. Now they kind of take you through the path that says, we didn't notice you had the Java SDK. Click here to download it. And so hopefully it will go a little bit smoother this time. So if you do not already have Eclipse, go to eclipse.org. I have a link to it in the homework. You can use the one from last semester. It's fine. You don't need the newest, latest, greatest. It's not that many updates. Or you can actually go into Eclipse and download. Should have just left it open. But from within Eclipse, I wonder if you can actually upgrade to Neon from Eclipse, or if you just get the latest.
I think you're 2 versions behind. 'Cause
Am I?
Mars, and I downloaded it last semester.
Oh, well, that's quite possible. Let's see. Check for updates. Let's see what pops up. See what it thinks I'm missing. So it was under help. No updates were found. So yes, looks like significantly behind. So while we're at it then, why don't I go ahead while I'm talking about the next stuff. Download from Canada. Okay, so we'll let that cook here. While that's going, I'm going to show you, this is actually related to your first, I also have a link here for the Java API documentation. Remember from last semester, something I kind of harp on is being able to read documentation, and we'll review that stuff. But when you click on that, it takes you to the entire Java programming language. And you can see there's lots and lots of stuff. You will have all that memorized by week 2. Okay. Most of our world of Java will live right in here, java.lang. So here's our little subset of the language that we'll be working with. And we'll come back and look at this, and I'll teach you how to use it and all that stuff. But there's a link to it in the homework, or in the course. All right, so here's my Eclipse installer. All right, so as you go through this, we want the Eclipse ID for Java developers, not the Java EE developer. So this guy up here. And by the way, I am recording. I record all my lectures, so I'll put it up on YouTube after class, so you'll be able to follow this and go and check it. All right, so I'm just going to choose the default install directory. I do accept it. I'm going to let that guy cook because it seems like it's maybe going a little bit slower than I would have expected, but it'll get there. So while we're at it, your first homework assignment is already up. It's under assignments. And again, right inside that assignment folder is this homework submission instruction. So make sure you review that before every single homework assignment so you can grab the template stuff. But homework number 1 is already up, and this is to complete the 12 parts of the Intro to Java section of a tool called Codecademy. How many of you have heard of Codecademy before? Okay, so again, like I said, I'm gonna try to take several different approaches to programming this semester. So hopefully everybody, hopefully we leave less of you behind. Is I think kind of the goal. So there are various online learning tools for kind of teaching yourself programming. It's kind of a big deal in today's world. We have a lot of people who have degrees in something else who want to go back and become developers. It's kind of a big industry now. So there's lots and lots of different companies trying to do continuing education for non-computer science students who want to learn how to become programmers. Because when you think about computer science as a degree program, you're learning more than just programming. So computer science is not programming. I want to continue to re-emphasize that. Programming is a tool that a computer scientist uses. It's one of our many tools that we might use to solve problems, to bend a computer to our will so it can do things for us. We use computers as our tool, and we use computer programming languages as our tool to tell a computer what to do. We might also use various other software applications that somebody else wrote for a computer to also make our computer productive for us. Okay, but computer programming is not computer science, but it is important for all computer scientists to have computer programming as a tool set. That doesn't mean that whenever you go into industry, whether you're in the IT industry or you're in the you're more of a computer science traditional type industry position, programming is still important. So for those of you who chose IT as your major, I don't want you to view that as, oh, IT is computer science without programming. Completely false. In fact, I might even argue that the type of programming you do as an IT professional is more complex programming than that you would do as a kind of a computer science traditional person. The reason for that is typically if you're a computer science major and you go and get a programming job, let's say, you're going to be doing application development, usually business applications. You're going to be using a professional level tool like could be Eclipse, could be Xcode for Mac, it could be Visual Studio if you're doing Microsoft stuff. A lot of you will be doing Visual Studio stuff. These tools are a lot of drag and drop with programming logic behind the scenes. So these are power tools that do a lot of the work for you. If you're an IT person, a lot of the programs that you're going to be writing are scripts that are going to run on some server somewhere. Okay, so for those of you who maybe work for IT here on campus, we have around campus, we have managed switches and stuff like that, these little computers that are sitting in a closet somewhere, okay? They don't have a monitor hooked up to them. You remote into these things through something that looks like, our terminal here. So you remote into this, and you're going to be writing software out here at the command shell. Okay? You don't have a little play button that says run my program. You're going to be compiling it and running it all from command line things. The skill set is a more complex skill set. What's happening behind the scenes in something like Visual Studio or Eclipse is the same thing. But as a business programmer, a lot of those things are being done for you. So you just have to worry about the programming side of things. As an IT professional, you're kind of working with, the underbelly of the the computer infrastructure for a place. From a consumer here on campus, if we're our job as a consumer here on campus is to be able to check your email and complain about the internet, right? That's what we do as consumers here on campus. Well, what delivers that internet is a humongous level of technology that is mostly in place to try to protect us. So when we complain that our internet is slow, at least it functions. And part of that is we have a whole bunch of stuff that sits between us and the actual internet that protects us from viruses, that protects the school from denial of service attacks. There's all sorts of stuff that happens today, and that IT professional is in charge of all that stuff, okay, and has to understand that. Plus, it's a thankless job, right? How many of you are going into IT? All right, so how often do you think people are going to say you're doing a good job? Never. When you're doing a good job, you're doing your job. They'll constantly say you're incompetent because the internet's down. why don't we just hire a couple of squirrels to do this job? They can do it just as well. You just sit there chewing through wires. Okay, very thankless job is IT. But I really want to impress upon you this idea that computer programming is just as much for the IT professional as it is for a computer scientist. All right, they're two sides of the same coin. Both sides have programming. Okay, the difference is whether or not you're going to be working directly with hardware and be more of a, let's say interfacing with human beings more often. So you're kind of that thing that sits between laying on the floor inside of a closet fixing some wiring on a switch and then going and talking to a person. Or you're the geek who sits at a desk for 8 hours a day, just pumps out software and probably doesn't have to interact with people. It's probably the kind of the two sides of it on the extremes. Both of them are doing software stuff. Okay. So in any case, where I was going with that is, let's just see where this guy is. Okay, so this guy says he finished. If it had found that I didn't have Java installed, it would have yelled at me and given me a link to go and download it. In this case, I think I already had it installed, so there's my Eclipse Neon. This thing pops up, asks you where you want your default workspace to be. I usually put it in a different place, so I'm going to set it in a different place next time, so I'll not check this box that says don't ask me again. All right. It was written with an older version of the product and will be updated. Okay, so it's telling me that I have 2 versions ago thing, and it formats the stuff differently, so okay. So there's my Eclipse. All right, so all of you should do that as soon as possible. Go through and grab Eclipse from eclipse.org. You won't need it for your first couple of assignments because we're going to be using Codecademy initially, but you will need it fairly soon. So I'd encourage you all to go and get that. No, I didn't ask for questions yet. Go ahead.
So I got a new laptop,
Okay.
and then I need to download Java. Do we want the JDK or the JRE?
Get the JDK. The JDK has JRE in it. So apparently it hasn't indexed yet, but whatever.
Do we want EU101 or EU102?
Doesn't matter. Get the newest, but it doesn't matter. Okay, so anyways, getting back to this idea of computer programming as a skill set that today kind of branches across multiple industries. A lot of people who didn't go to school for computer science or IT are going and trying to learn computer programming as a skill set for many different reasons. First of all, you see computer programming becoming part of a lot of different industries. And sometimes it's not, oh, we need this professional level piece of software written for us, where you maybe would go out and hire a place that does programming day in, day out. But maybe it's the type thing where, hey, we have some new tools in the office that have a scripting language associated with it, and we need that person at the office who is our go-to person for writing our little scripts for automating some of the stuff. That's a computer programming skill set. So to get that skill set, you might go to, you're probably not going to go and pay for a 4-year degree. Okay? You're probably not going to go to a university and pay the a high price for these courses when you don't need a degree, you just need the skill, right? So there's all sorts of places online that you can go that kind of teach you computer programming through kind of a crash course type thing. It's not the type thing that you would go from being a beginner to a professional programmer. But it shows you enough to be dangerous and enough to know whether this is kind of up your alley or whether this is something you want to hand off to somebody else if you're that person at the office. Now, there's many of these to choose from. And actually, let me go ahead and while we're at it, let's just go ahead and start our keynote presentation. So like I said, and most of you have had me before, but for those of you who have not had me in class before, I always record every lecture, so every now and then we might have a failed recording, but most of the time it works just fine because I don't use our on-campus Panopto thing because IT is incompetent, right? Panopto for the Mac is hit and miss. It's just the tool that we officially support that as faculty we're required to use. I don't use. Yeah, I use my own stuff because I'm a rule breaker. So in any case, I record it on my machine and I upload it to YouTube. And I'll put a link to the channel for the class on there so you can go back. It's a good way to fall asleep at night, is to my voice, I've been told. So you can go back and review any of the lectures and stuff like that. Maybe you go through and look at the Eclipse part of this or something like that. But they'll always be up there. Or if you are sick or you do miss a class, you can go and review the class. So it's a decent way of doing that as well. So in any case, that'll be up there. Also, the lectures or the slide set for the class, I also keep up there. So I share it with iCloud and put the link up there so you'll always be able to see it. So we'll go ahead and start. CSC 250. This is, what year is this? 2016? Ay. All right, so let's talk about online learning tools a bit. Go ahead and save this so I don't forget. CSC 250, fall 2016. Okay, so the one we're going to use in here initially is something called Codecademy. And I'll introduce that to you here in a few minutes and kind of show you what your first homework assignment is going to look like. There's some other ones you may have heard of. Team Treehouse is another one. Then we have Udemy, Udacity. So all of these guys are kind of similar. That is, they are relatively inexpensive. All of these have a free version. We're going to be using the free version of Codecademy just for intro stuff. You won't be paying for Codecademy. If you like it and you want to pay for it, you can, but that's not going to, you won't have to for part of the course. But basically, each one of these has various programming technology courses available, and they give you like a portion of that for free. And then if you want to do the more advanced topics or have projects or stuff like that, then you pay them or something like that. But even when you pay them, it's something like, you know, $10 or $20 a month, that kind of level. So these are mostly learn at your own pace, and you're pretty much reliant on yourself for exploration, for going deeper into the stuff. So I usually refer to it, I say it's a lot of monkey see, monkey do. So Codecademy does this less, but Team Treehouse, Udemy, Udacity, these do this pretty regularly, where you basically watch a video and you mimic them. You just do the stuff along with the video, and when you're done, your stuff works the way their stuff works because you did exactly what they did. Well, that's great, but that doesn't mean you know how to program. Okay, so Michael Jordan teaches you how to shoot free throws for an hour, and in the end, you are making some free throws. Well, you're probably not going to shoot free throws better than Michael Jordan did. You know, we're using this example like Michael Jordan's still, you know, like a top player, but he's better than us, right? Well, he may be not better than me. I'm an amazing basketball player. Huh? Is he better than you? He's probably better. Anybody in here play basketball? So he's better than all of us. Definitely better than all of us. Even if we did play basketball, I'm sure he's still better than all of us. So in any case, those kind of monkey see, monkey do type tools can be beneficial. And this is kind of related to why I'm taking some different approaches in class this year. So we look at last year, where you might see me up here writing something when we were doing Java, and it looks very easy. And then when you go home and do it, it is more difficult. You introduce little bugs into it, and you know, typos, and like, oh no, my code's exactly like yours, until you realize it's not, right? But you know, the point is that when you see somebody who's done it before do it, it looks easy. Okay? When you see a great soccer player do some amazing footwork stuff, they make it look easy. Okay? Where most of us would just trip over our own feet, all right, trying to do that stuff. So sometimes the whole monkey see, monkey do approach isn't the best for some people. Because what you kind of need to do with that is you watch somebody do it, you mimic it, you get yours working like they did. Then you say, okay, what can I now do with this new skill to modify this and make it do something else? Right? So now you're going to challenge yourself and spend another 20 or 30 minutes with the code you just created and break it, change it. Like, oh, if I did this, what would happen? So kind of experimenting with it, seeing what it can do, and kind of learning on your own through exploration. Okay, so the whole monkey see, monkey do approach really benefits if you take that next step to do that kind of stuff. Some of us do, some of us don't. Okay, so it's good for some learning styles, not for all learning styles. So these guys are pretty much like that. Codecademy takes a little bit of a different approach, where it gives you a tool, and there's several other ones that do this as well. Just Codecademy is the one that I'm using in here. But they give you a tool for doing this all online. So you won't be using Eclipse for the Codecademy stuff. You'll be using their own little thing built right into the website. And they say, here's a starting point for you that doesn't have what we want you to do done. Here's what we want you to do. Now go and do it over here. And it'll give you error messages coming back. So it kind of gives you almost like a puzzle type thing to work on. All right, so that's a little bit less hand-holding, right? You're not just mimicking what you see. They've given you enough to be dangerous, but they've left several of the puzzle pieces out. And you got to go and manipulate it and kind of get it working. All right, so that's another approach that we're going to take in here. Now, an approach that we are not going to take in here, because kind of our lectures, hopefully, and our homework assignments replace some of this, but there are some tools out there. The one that I consider maybe the best is a place called Thinkful. And so we might say all of these guys are cheap. So these are all free, or even the professional version of it is pretty inexpensive. 20 bucks a month, something like that. You know, you skip a pizza or two and you got it. Now, something like Thinkful, so we're going to call this moderately expensive. So this guy, you know, they have sales all the time, but figure this is about $500 a month. Okay, and the way Thinkful works is they have effectively courses that you go through. So they have a curriculum. The courses have lecture built into it where you read about the stuff. Then they have projects, so it's project-based learning. So they teach you something. You have some examples that you go through and learn, and then they say, okay, now take those skills that we just taught you and do something that we're not going to give you any starting point for. So do it from scratch. So first of all, it's going to take a lot more time because you're very reliant on yourself. And then you also meet with a human being once a week. So you meet with a mentor who you can ask questions of and that kind of stuff. So there's a human being associated with it, with something like Thinkful. So I kind of look at Thinkful as like kind of the tool in the middle. And there's a couple other places that are similar to this. Then you have what I would just categorize as boot camps. So these guys are very expensive. I was talking to a guy this morning who's going to something called Coding Dojo. So that's one of these. There's several other ones. And these are effectively focused, think of it like college. Focused college, but only for programming. So you might go to one of these, and it might be a 2-month or a 3-month program where you program for 10 hours a day, every single day. Or maybe it's the weekends off or something. I don't know the exact thing for all of them, but it's very, very, very intensive and all programming. And it might be like $15,000 for 3 months. Okay? But the idea is that a lot of them like guarantee you jobs when you're done. Some of them do scholarships where you pay like an upfront fee to like say you're committed to doing it, and then that gets refunded at the end, and they guarantee you'll get a job when you're done. But they take like 50% of your first year's salary, something like that. That's some of the business models they use. But so this is kind of evidence that there's people switching careers into computer programming, computer science, because jobs are so prevalent with it. Makes some sense? So lots of different tools that are out there. The hope is that what you're going to get through our program is something pretty close to this Coding Dojo, except you're getting it across 4 years rather than across 3 months. Now, my argument is across 4 years is better than across 3 months. This goes right back to that example of if you went to Michael Jordan's basketball boot camp for 2 weeks, even though you're getting intensive basketball study done, 2 weeks isn't enough time for you to incorporate all that muscle memory, all the, you haven't had time to practice. So 4 years seems like a long time, but you have lots and lots and lots of time to get good at some different technologies. And another thing is with programming is it's not so much about learning what does work. It's figuring out and screwing up all the times and figuring out all the things that don't work. And that's kind of the philosophy behind my self-assessment stuff for the homework. You might spend a ridiculous amount of time in your homework, an unreasonable amount of time in your homework. You know, somebody who's kind of maybe a little bit ahead of the curve might spend 45 minutes on an assignment that you spend 10 hours on. And at the end of that 10 hours, you might have said, you know what? I tried about 30 things and none of them worked. But you know what? I know that those 30 things don't work. I went down the path for each of those 30 things, had a whole bunch of stuff written that didn't work. That's learning. That's important learning that took place there. Okay? And I want to reward you for that, hence that self-evaluation thing. Because you're probably not going to try those 30 things again next time. Maybe you only try 12 of them. Because you'll screw up and whatever, but you know, you at least learn from some of your mistakes, right? You know, that's the hope, is we all learn from our mistakes. So we need that time to screw up. You know, I'm an avid golfer. So when I first started golfing, it didn't matter how many times somebody showed me how to hit a pitching wedge, let's say. You know, I could step up there and they could put me in all the right grip position, and then what do? I step up and shank it. Like, well, that was crap. You know, then 1 out of 100 shots, I hit it great. Does that mean I can hit it great very often? I just know I'm capable. I just know somewhere inside of the swing there exists that. Okay, and then through practice and hitting thousands and thousands and thousands of shots, you end up doing it more than 1 out of 100. Maybe it's 1 out of 5, 1 out of 3. You know, the pros hit it 1 out of 1.25, something like that. So, you know, the punchline is just like any of these other things, programming is like a sport, and you're going to have to put in those reps if you want to get good at it. And regardless of what your major is, whether it's CS or IT, I'm telling you, you need to get good at it. All right? You don't need to be the best, because at any job you're going to have, there's going to be go-to people for different things. All right? So in IT, you might have the guy who's kind of the programming guy. So whenever you need to do scripts at the server level or something like that, you go to him. But then you have the dude who's maybe great at wiring. Okay? He might also be the littlest guy. Who can get into the little tiny things. That was always me. What? No, you're way too big for that. I'm surprisingly petite. But in any case, with any job, you're going to have people who have different focuses, different talent areas. So don't feel like you're screwed with IT or computer science if you're not the greatest programmer. But you still need to have a minimum level of competency. That's what we're shooting for here. Some of you are going to be very good at programming and are going to like it. Okay? Some of you are going to be decent at programming, but aren't really going to like it. You're going to work hard to become decent at it, but you pretty much know this isn't really what you want to spend your day doing. Some of you are going to kind of suck at it and hate it. That's okay. That doesn't mean you're not cut out for IT or for computer science. It just means you're going to have to find your niche in that area, but you're still going to have to hold on to that skill so you at least know enough to be dangerous. That type of thing. Okay. Questions about any of that? All right, so we're going to be looking at Codecademy here for a few minutes and kind of taking you through what your first assignment's going to be. So your first assignment is effectively kind of a crash course review on what we did kind of during the last maybe month of last semester. So let's go in here. So I'll go back into here's the actual homework assignment. And I give you the link to it here. So complete the 12 parts of the, shouldn't this be bigger text? That's a lot better, isn't it? All right, good. So complete the 12 parts of the Intro to Java section on Codecademy. Here's the link to it. I'll just copy it and we'll paste it in. Submit a screenshot of the list of 12 sections all unlocked as proof that you have completed them. And I'll show you what that means here in a second. All right, so let's go ahead and paste this guy in. All right, so only upgrade to Pro if you want to spend money. You don't have to for here. So in any case, this takes you to the Learn Java thing. When you sign up, I think I signed up with my GitHub account. So before you'll have to create an account or whatever, and you have a couple of choices. I think you can log in with Facebook or GitHub or create an account with them. So create your account, and then once you're logged in, you'll go to this the Learn Java Basics. So I'll just hit continue on this. I don't remember. I think I just looked at how it worked. Which thing am I on right now? So this takes you to a screen like this. Let's go with that for right now. Here we go. So let's go back to what's your name. So this is equivalent to our Hello World exercise. All right, so you read this little blurb over here that gives you the intro on what Java is, blah, 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 and ultimately teaches you about system.out.println and how printing stuff out to the screen is accomplished through that. All right, and what they want you to do is they want you to put your name in here, and I had previously done this, so my name was already inserted. I think by default they have it set up like that. So it would be an error. Actually, it wouldn't be an error, it just wouldn't show anything. So they want you to go ahead and put your name in there, not make any mistakes. So, you have an opportunity here to forget to put the closing double quote on there, that kind of stuff. But get your name in there, hit run. It's going to do its thing here, and we'll see what it looks like over here. But there's your output. You saw it work. Okay. So I'll go ahead and hit next. We'll go to the next lesson. Next lesson, what do they want you to do? So they're teaching you about some data types. So remember last time we talked about the primitive types in Java, the types that can only hold a value. We'll review them here in a few minutes maybe, or at least next class, but you'll get reacquainted with some of them. But you have byte, short, int, long, char, float, double, Boolean. Okay, these are our types built into the language that can only hold a value. So they're reintroducing the integer type to us, which can hold whole numbers between -2 billion and +2 billion. It's a 32-bit number, so that's -2 to the 31st power to +2 to the 31st power, because one of those bits is used for positive or negative. All right, and we'll review all that. But in any case, they're teaching you about the int type, so you're reviewing that. Here's your -2 billion to +2 billion thing. So they want you to type any whole number between the parentheses, blah blah blah. So we'll just go in here and put in a 5. We'll hit run, and it should print out. Oh, what is it? What's it complaining about? Oh, I must have double clicked when I. So there's our 5. It's happy. We printed out an integer. So this would be called a literal type. So that's the literal value 5, as opposed to a string mic or a variable that resolves to its value. So keep hitting next, go through all these. So in the end, after you've done the 12 sections, see how there's little check marks next to these? What I want you to do, so you might have to zoom out so everything will fit. So here's the 12 here. Do all 12 fit there? Yep. So I want you to take a screenshot of this to hand in, and you should have check marks next to all those. Okay. On a Mac, you can do Control. Was it just Control-Shift-4? We'll give you like a little arrow. You can draw the box around it like that. I think what is it? Just
Snipping tool in Windows.
there's a way to just take the full screen on Control-Shift-3 does the whole screen. Yeah, so that just did everything that's on the screen, and then snip it on Windows, so it's take a screen capture. Make sure I see this part. Okay. If you didn't get all of these done, you can use the self-evaluation to tell me why. Now, one thing you're going to struggle with for this, though, is you won't really be able to skip a section. I don't think you can skip a section.
No.
Let's see if they'll allow you to fill in the answer, to give you the ability to see the answer. I mean, they kind of give you instructions, so you should be able to get through all of it, I would think. But in any case, if you can't get past one of them, that's when you might use Slack to ask for help. Email me if you're struggling with it. Just tell me what you're, tell me what you're supposed to do, or at least which lesson it is, and maybe paste in the code you're currently working with and say, I don't know why this doesn't work. I can respond back. But probably Slack's the best way of doing that. That way, I might be the one who answers, but maybe another student answers as well. So, get through this whole review process, blah, blah, blah. Make sense? So the homework assignment for Thursday is to go through these 12 lessons and show me 12 check marks, which means that I will know that you went through and have a review of ints, booleans, chars, what variables are, the idea of white space, how comments work, your math operators, the remainder operator, modulus, relational operators for booleans, that's the and the or, quality operators, and then generalizations are kind of another Java thing. It's a really short section actually. But so you should have check marks next to all of those showing that you know how that stuff works. Make sense? Okay. Now, let's start reviewing some stuff then. I guess before I jump into that, any questions about any of the stuff we've talked about so far in terms of the course, what you have to do for Thursday, what you have to do in terms of Eclipse and Slack and all that stuff, and be prepared for quizzes, and we're good? So everybody's going to get an A? I doubt that will be the case. I don't think I've ever given all A's. I've given no A's a few times. I love those because you get the crying. Yeah. It's my hobby, is human misery. I'm a fan. All right. So let's go back here. And just to kind of go side by side with the stuff that you're going to be doing in this Code Academy dealie, let's talk about our primitive types again. So some of these are going to mimic some slides that you had from last semester, but we'll spend a couple of days reviewing to get you caught back up. So if we were to define primitive types, anybody remember? I already said it once today, but anybody remember what a primitive type is from we talked about last semester? You had to define it on a quiz. What would you say?
Variable that only holds a single value.
Okay, so a variable type built into the language that can only hold a single value. It doesn't necessarily have to be associated with variables, because like we just looked a minute ago at the number 5, which isn't a variable, but it is an integer primitive types. That would be a literal, but primitive types only hold a value. That's the deal. So variable type that only holds a value. All right, and more importantly for us, so really what we want to remember as it relates to primitive types is we want to remember this idea: primitive versus object types. So it's less about knowing the exact definition of primitive type versus object type, or object type. It's more about understanding the differences between primitive types and object types. So primitive type variables can only hold a value. That's the extent of its talents. Okay? Object type variables can hold 0 or more values. They don't even have to hold a value, but can potentially do more. So they can have methods associated with them. To remind you from last semester, we had looked at strings quite a bit. And so with strings, we could get the character at a certain position. We can get the index of a certain character in the string. We can get the length of the string. So strings knew how to do other things other than remembering the collection of characters that were associated with the string. Make sense? So that's an example of an object type, would be a string. So objects are kind of super variables. Primitives are kind of simple variables. primitive types. We have byte, short, int, long, char, float, double, and Boolean. Okay, and as we talked about last semester, where almost all of our modern programming languages all derive from the C programming language, all of these match the primitive types of C. So what I have highlighted right here are the primitive types for C, C++, Java, C#, Objective-C, Objective-C 2.0, and pretty much Swift. Swift changed some names and stuff, but all right, so pretty much all of our languages match that. All right, now Booleans exist in all of those as well, but this is the one place where things change up just a little bit. So, for instance, in Java, it's Boolean all spelled out like this. In C, Booleans are actually represented as integers, 0 or 1, on or off or on. In C++, Boolean is caps, all caps, B-O-O-L. In C#, it's B-O-O-L lowercase. So little changes in the Boolean name across them, but generally speaking, these are your primitive types across all C-based programming languages. All right, now specific to Java, we want to understand the need for these different things. What time are we out? Are we out at 11:20, right? Yeah. All right, good. So somebody told me to shut up at 11:20. So first of all, bytes hold whole numbers. Shorts hold whole numbers. Ints hold whole numbers. Longs hold whole numbers. So as a review, why do we need so many different ways to hold whole numbers? Technically, these are positive and negative whole numbers. So a byte can hold -4, it can hold +4. A short can hold -4, +4. Int, -4, +4. Long, -4, +4. Why do I need so many different ways of holding whole numbers? Okay, tell me more about that. The answer is yes, you're right. Okay, so memory used to be really expensive, right? How many of you, out of curiosity, are taking the 325 class this semester? There's one of you. That's kind of going to be our conversation in there. So 325 is computer organization and architecture. And what we talk about, so in here, we're talking a lot about the software side of things. And one of the things I emphasize, as you know, from last semester, you remember, we talked a lot about what's happening under the hood. Well, 325 is all about under the hood. So we'll get into a lot of depth about that whole memory thing and why it was more expensive and all that stuff. But so understanding this stuff is that we have a whole course on what's under the hood. In here, I'm just kind of glazing over kind of what's under the hood. So punchline is memory used to be really, really, really expensive. The price of memory and the speed of memory, as well as the amount of memory, has come way down in price. And something that we'll talk about later on today in 325, but it's an interesting quote, so I'll actually share it in here, is we can all agree that computers keep getting faster and faster and faster, right? Okay, so if we go back to in the C programming days, 1968 or so, memory was really, really, really small compared to our today's standards, right? Today, you buy a new laptop, it probably comes with 8 gigabytes of RAM. You know, laptops didn't exist in 1968, but you buy a computer the size of a gymnasium in 1968, and it probably came with like 1K of memory, 1 kilobyte of memory. A tiny, 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 tiny fraction of what our laptops come with today. What's in our calculators today, okay? So, and it used to cost ridiculous amounts of money. So the interesting quote is, when we think about kind of evolution of computers, how they've gotten faster, we probably all predict or could guess that computers keep getting faster and faster, and especially over, let's take the years like in the 90s. I mean, you would have huge jumps on on a weekly basis with computer technology. That was kind of when computers were going from almost nothing to, from a consumer perspective, to a lot of something, right? So the comparison that the book for the organization class makes compares computing power to the automobile industry. And an interesting thing was, if automobiles, our automobile technology, improved at the same rate as computers had, how long do you think it would take to drive from New York to London? Distance-wise. I realize there's ocean there. Just take a wild guess. And how much would it cost? So if the automobile industry improved at the same speed as computers had, how long would it take to drive from New York to London, and how much would it cost? Huh? 9 seconds? Microseconds. Okay, that's closer than a couple of minutes. It would take about a second to drive from New York to London. It would cost a penny. Kind of an interesting way to think about it, isn't it? When we think about how fast computers have gotten, relatively speaking, and how slow automobiles still are, relatively speaking, if automobiles sped up at the same speed, we would just be able to drive from New York to London in 1 second, and it would cost us nothing. Nobody carries pennies anymore. People would, on the other end, would just say, forget about it. This is no big deal. So kind of an interesting thing. So in any case, these primitive types, like I just shared with you, since they came from C, the C programming language in 1968, back when memory was really expensive and very small, we needed multiple ways of representing whole numbers because each of these has a different memory footprint. So a byte is 8 bits. A short is 16 bits. An int is 32 bits. And a long is 64 bits. Okay, so that's a bit is a 0 or a 1. So to represent a byte, we need 8 zeros or 1s. That's a lot less. That's half the size of what it takes to represent a short. Okay, so like the number 1 as a byte looks like this. The number 1 as a short looks like that. Same value, but a short's going to take up twice the real estate. Make sense? I can keep going down the line, but this one might wrap. This one definitely wraps. So 63 zeros followed by a 1. 31 zeros followed by a 1. Right? They have different sizes. So if you don't need to hold a value larger than what we can capably hold here. So a 8-bit number can hold values in the range of -128 to +127. That's the range of values that we can represent in 8 bits. So if you don't need to hold a value larger than that range, use a byte. That would have been the historical way of looking at it. Today, we don't care. What's the difference between a byte, a short, an int, and a long in terms of the amount of memory we have in our computer is negligible, right? So your modern programmer uses an int all the time. If that's not quite big enough, they use a long. If that's not quite big enough, because they're doing some sort of scientific, research type stuff where it's accumulating gigantic numbers, then they move over to an object type that can hold arbitrary size values that just has performance implications. Make sense? All right. So homework's due Thursday. Make sure you get it in before class starts. Probably won't have a quiz on Thursday, but we might. It's always a risk. Always a risk, but could be. All right, and get signed up for Slack, and if you have any questions or have problems with the textbook or anything, shoot me an email or text me or hit me on Slack, and we'll get everybody up to speed this week. All right, have a good one.
Just don't use a separate word for grade 25, because then I'll have to remember which is which.
That'll just be funny, though.